and let's talk about Shoshin now. So Isaac was our experiment last August. Three-body problem. Alpha Centauri is like the solar system but with 3 suns. It's like in a story where if you live in a planet surrounding 3 suns, then everyone can die anytime soon, and it can get super hot, it can get super cold if you're away from the sun. Very unpredictable, right? Unlike our solar system where we can just go around the sun. Pretty much the same. So we made a game like this, but we simulate the 3-body gravitational system in Cairo smart contract, so no one can cheat, no one can change the physics. And the game was played in a way that the players will work together to pilot the planet to go around the suns. If they don't pilot together, the planet crashes into the sun and everyone dies together. But if they pilot around the sun through coordination, everyone wins together. We wanted to do some coordination game, but also involving physics on chain. This wasn't going really well because TPS was unstable, and every single move is a transaction, so it's slow, unpredictable, unstable. We realized that this thing is not something that is native to the medium. That I think it's important for design to be native to the medium. Like one example we like to make is that imagine having drawn on paper your entire life, and then all of a sudden clay comes out and you can mold the clay into sculptures. But before doing that, you kind of just take your pen and draw on clay. You thought that's just a new place to draw. But ultimately, clay is something you can mold into spaces and structures, having more dimensional than paper. So the design and the aesthetics on this new medium will be very different from what's on the old medium. And we think that blockchain is not really good for turn-based games, in a sense.
Yeah, and I think one good analogy that we can use is that anytime humans had these aspirations to put worlds into machine, to reenact our imaginations into computer or the machines that we are capable of. So first we probably had stones, where it's like a static palette where you can put stuff, and we put games like a Go's or chess over there, and we figured out the computer or machine arcade. So people start putting worlds in there, simulate the worlds in there. You know, we have computer, phone, yada yada yada. But as you can see, whenever we have instance where the medium on which the world can be hosted, so think about Go, chess, it's a static, just a non-changing a board or paper. You have certain games that is worlds that are native to those medium. We have arcade, so you need a separate machines, it can be connected to other machines. We have separate worlds that can be hosted in that world. Same for your computer or gaming console, you're connected to your TV, or your mobile games. The worlds on which that are hosted is quite different, because if you look at your phone, Angry Bird is more native to your phone games or phone worlds. There's also different types of worlds that can be simulated or through your computer or TV game console. So our thesis is that we are seeing this world computer getting faster, so we are now possible to simulate some kind of world. That's why we did like a two-body physics simulations, not knowing this before, but we just did it for fun. I think it's always true. You can only connect the dots looking backward and seeing our progressions and feel like, oh, that's what it was. So we did some fun physics simulations and figured out, oh, we can actually have worlds on blockchain, and thought that, what does that really mean? Like, why do we need to put worlds on blockchain? And we thought a little bit, be like, oh, okay, I don't want to live in a world, if there's ever like this virtual world or metaverse or whatever you want to call it, I don't want to live in a world where it's owned by, I don't know, Kakao, Naver, or Meta. The reason why we can have, it's like living in a world where tomorrow Meta says you need to wear a different t-shirt because, I don't know, whatever their reasons are. We thought that that world is quite not optimistic from our perspective, or anyone's perspective. And that's where we thought about, oh, how can we make digital physics, everything on chain, so that in the worlds that you have right now, virtual worlds, we can say computer games, Diablo or MapleStory or League of Legends, none of them are connected because the physics part or the underlying infrastructures is owned by some entities. So it's impossible to connect them. Just like imagine a world you're living in South Korea or United States or Japan, some overlords own the entire logic that goes in that world, and they can change anything. But the world that we're living in is we're all governed by same laws of physics anywhere in the world. at least in this world. Who knows what kind of simulations there are. But if you're living in this world, we're governed by trustless, immutable, open source laws, and we are governed by it. Nobody can change it. It's just observing. So if you go United States, you can drop a pin and calculate, I don't know, gravitational force anywhere around the world. That's how our thought was. Okay, if we can do this two-body problem, we can actually make worlds that is governed by trustless, open, immutable rules instead of relying on some entity or person at their mercy. So that's kind of what we thought, and we thought the world computer is coming about. So we need to figure out what is the best way to create the world in this medium that is completely new. So we don't think that putting MapleStory or League of Legends on chain is going to give us the insights or the future that we think. We don't think putting everything on chain, or I don't know, or just using the same Unity or Unreal Engine and putting NFTs or tokens is the way to make on-chain experience. But to understand this philosophical debate about what kind of world that we should reside in, it is more crucial than actually creating fancy-looking, AAA grade graphics going around, because we're at an age where we don't really know what needs to be on-chain and why things needs to be on-chain. I think those are more crucial answers to make. And then making things pretty and graphics and sound effects could happen after. And I think that's why we do a lot of experimentations. Isaac was one of them, and we figured out, okay, the world computer that we need to host the worlds on, the DPS still is not as good as having anytime real-time interactions. So I think that made us move on to the next iteration. So a lot of people ask us, why are you guys changing or dumping games or changing games all the time? Because our objective is not to create massively used games and have our metrics is not about like DAUs or MAUs, because it's more about proving our hypothesis or falsifying our hypothesis and try to figure out what is native over here. So our next experiment was Mumu, and I'll let Guilty Gyoja to explain this complex simulations that is being shown over here.
I think it looks complex, but it's really welcoming actually. So it's a game about making a factory pipeline that transform one emoji to another emoji, and you are provided with wood on top left. The goal is to synthesize fire and put fire to the top right. The way you do that would be you have a lot of little hands, right? Picking things up, move around, and dropping them. So that's one component. The other component of the game is formulas. So these are colored stripes on the board. Every stripe is a formula, kind of like alchemy. You draw a pattern, and the pattern can do some magic. So if you look at the green formula on top right, it's able to take 2 wood and produce a clover at the equal location. Right? So these are different formulas that can take different stuff and produce different stuff. The goal is to make a pipeline that can produce fire. So that's Mumu, and of course the simulation is in Cairo smart contract. So what's off-chain is these emoji, the graphics is off-chain. And these are player submissions. So they're submitting different designs, these formulas placements and little hands placements that are able to deliver fire at different amounts over the same period of time. So that was going quite interesting. The top solution delivered 39 fire and 150 frames. The best I did was maybe 5 fire, so I really understood how the top player was able to do that. And we're fascinated by, I think, how eager and thoughtful some players really are, and they're able to, there's no incentive here. There's no NFT drop, no token incentive. It was just, we're doing some weird stuff on Starknet. Come try it out, it's free. So that's pretty interesting. And then we feel intuitively that this field has something, part of something bigger, and we wanted to find that bigger thing, in which Mumu is just a part of it. And that eventually led us to Shoshin, which is the topic for today. Shoshin. So Shoshin is our current focus. It's a fighting game between the minds. So normally if you play fighting game, you are pounding at your keyboards, right? Trying to remember the combos and do like, like up, up, down, down, left, up, right, right, A, B, A, B, the combo keys. But in Shoshin, you play by designing a mind, like a brain, that makes decision. And you submit that decision-making brain on chain, and it battles other minds. It's automatic. One funny thing about this pattern is we are TPS agnostic, because the only transaction you're making with the blockchain is when you're happy with your mind and you submit it on chain. And then in one transaction, it battles other minds. So TPS fluctuates, doesn't matter to us. We're kind of taking to the extreme. It's like we have like traumatic experience with Isaac. Let's just do something that is TPS agnostic, completely agnostic. And so once you have the brain, what the brain does is the brain produces intent. Like the brain tells the body what to do, that's intent. Like I want to move my hand, or I want to walk over there, that's the intent. And the intent will drive the body. And the reason why there's an intent layer here is sometimes the body doesn't do what the mind wants to do, hence all the interestingness of humanity. And so for example, if I am in midair and I want to kick, but there's no kicking in midair, my body doesn't respond like that, so my body won't kick in midair. Etc. Like when my body is exhausted but I wanted to punch, my body won't respond. So the mind-body separation is what's called in psychology, but we're sort of replicating this model in smart contract. And the last step is physics. So when the body moves around, punching, dashing, jumping, physics simulation needs to happen to compute, am I landing my punch on your body, or if I jump, right, the gravity acts on me, so I am moving along the y-axis, where am I in the next frame, and so on. These are physics simulation, and we were able to do this in Cairo smart contract. So this is the game loop. When you play Shoshin, you submit the mind, and then in the VM, we do 4 steps. The first step is the mind perceived from the environment, public variables, such as what is the HP of my opponent, or what is the velocity of my body. These are perceptibles. And then the mind would make decisions on the perceptibles and make intent. What do I want to do next? And the intent will drive the body, and that results in physics. So my body moves around. I may be jumping into midair and so on. And then physics simulation happens that compute the interaction between the two. So now it's 1v1, so just 2 characters fighting. And housekeeping is just calculating how much HP, stamina everyone has left. And finally, front-end renders everything. So we're not crazy enough to run graphics on-chain yet. And I think there's consensus right now that fully on-chain game doesn't have to run graphics on-chain. That's still, I think maybe in 2026 it will change, but right now we can safely run graphics off-chain and say we're a fully on-chain game. So this is the early footage internal playtest. What you can see here is the female character really doesn't get hurt. The reason is the dash is invincible. Well, while you're dashing, the frames are invincible frames. So you can basically dash into an attack, and Jessica's special ability is she can cancel her dash into attack. So normally if you play fighting games, like the moment I want to attack to I'm really attacking, there's a latency because I need to prepare. I need to draw back my arm and so on. That's the preparation frame. But Jessica's ability is if she is dashing and attacking while she's dashing, she can attack immediately. She can skip the preparation frame. And that's she's able to basically overpower the male character. And this is just to show that we have a debug mode, so you can see the hitboxes. These hitbox, right, the shape, dimension, the position, these are computed in the smart contract. This is what happens in the physics simulation. So like hitbox overlap, so they should bounce back and so on. And we also have a real-time mode. So in early playtesting, we realized and we got feedback that if I make a brain and I want to test my brain, it's simple if I can basically play against my brain in real time. So I design something and I put it as my enemy and I play against my mind to feel what he or she can do. So we have a real-time mode where you're just playing with your keyboard. I think right now playtesters are having a lot more fun here than the brain design part because it was still quite complex. Okay, so a little bit more into details. Perceptibles are everything that's publicly observable, right? So my and opponent's whereabouts, HP, stamina, what the body is doing, which frame of the body is in. And these perceptibles are being used to make decision. In game industry, there's a standard of representing decision-making in finite state machine and behavior tree. So that weird combination of letter, that is basically hierarchical finite state machine behavior tree, a hybrid. Last H is hybrid. So state machine is, you can inhabit one state any given moment. And the way in which the state transition to different state is through evaluating conditions. So condition is such as the blue words here. If my opponent is vulnerable, if this condition evaluates to true, then I go to attack. Otherwise, I stay in wait. I keep waiting until my opponent becomes vulnerable. You have mental state, and you go between mental state if certain conditions become true or become false. And Just a technical detail, conditions is represented as binary tree in the smart contract. A binary tree where every node is an operator, and you can evaluate the tree, and that evaluates to the trueness of the condition. That is a Boolean value. Okay, for those of you who may have studied state machine before, computer science training, we're basically running a Moore machine. What this means that is in one mental state you produce one intent. So it depends on which state you are, your mind sends one single intent to your body. Trying to make this as simple as possible. And then moving on to the body. So body is basically animation state machine. If you use Unreal Engine, this is anim state machine. Is if I press space, my character go to jump, and he runs a jump animation. That entire transition in Unreal Engine is a state machine. So we're just replicating this in a smart contract. So every playable character is a state machine that can do different stuff, the move set, the different actions that the character can do. And finally, there's physics. So physics basically here running a first order extrapolation. So everything moves around, right? And so the way we do it is, this is a very simplified way. If you play like Valorant or any AAA game, the physics underlying is 1,000x more complex than this. This is toy to them, but I think this is quite new to blockchain. So we're making an extrapolation. Like if I want to move forward, I'll move forward. I'll try to move forward, but then I may run into a wall as I move forward. So we need a second step that reconcile that. If I run into a wall, I need to snap back. I cannot run into the wall because the physics of Shoshin is that you cannot run into the wall. We say that. So that's physics. And this is the interface where players create their minds. So state machines. The mind transition between mental states, and they do different stuff in different mental states. This is just an example of a condition called close, which is, am I close enough to my opponent? And it reads very simply, right? Absolute value x difference is less than 80. We also have a window for debuggability. So that basically means that if you think that your brain is performing something unexpected, you can look into the raw data and try to debug your mind. I think we may need to use a different word because debug is too programmer specific, but we don't want the player to be programmers only. And this is basically showing frame by frame the thought process of each brain. So we're currently doing playtesting. Last cohort completed. We have a QR code that you can scan and join the waitlist. We'll let you know when we're ready for you. And the QR code will be available at the last slide. Art is important. Despite everything we said about video games being purely abstract, the beautiful stuff can come later. It's important to consider aesthetics. So we're redesigning character concept, trying to make a character that is well-rounded in the statistics. Not super high damage, not moving super fast, but just like balanced. Maybe Panda is a good option. We're re-architecting everything in Cairo 1, so this is more ecosystem specific. Cairo is going to upgrade from 0 to 1, and we're taking the chance to optimize everything. A number for you will be the cost of simulating 120 frames in one transaction. That takes 0.0004 ETH, which amounts to less than $1, assuming a 2K USD ETH. So I think that's quite acceptable, running something as complex as this. But this doesn't mean that this is scalable, right? Because this is 120 frames, but in modern video games, we play at 60 FPS. So 120 frames is just 2 seconds. You play for 2 seconds. So you want to play for 30 seconds, and if you want the brain to be really complex, like interesting behavior, like cheating, fake moves and so on, all the game theory stuff, this thing won't fly. So which brings us to, I'll talk about this frame first. So this slide is the way we think scaling can happen. So we need to take the compute off-chain, kind of like roll-up, but I think industry consensus now calls this client-side proving. So you run computation client-side, you prove the entire execution, and you send the proof to other people, maybe verify on chain. And so in the context of Shoshin, this is important because in this world, right, our brains are opaque. Like, I don't know what you're thinking, and that's great because we have privacy. But right now, Shoshin on chain means that every brain is transparent. If we want to host tournaments, it may be strange that if I submit my best brain into this first round, then it's open sourced. Everyone knows I lose my competitive edge. So client-side proving basically allows us to run a fight between two brains, but keeping the brain opaque only to the creators. So we think this is really important to preserve like intellectual property rights and so on and so forth. If you want to run a betting on the fight, I also think it's important to support kind of like an economy that surrounds these intellectual properties. Intellectual property is just a word that we use to describe these brains. Players spend so much time designing the behavior, it's an intellectual property. Great. So coming back to this slide, we're calling this application-specific VM. We haven't really started this step yet, but the idea is pretty simple. So Shoshin is a game where you design minds, and in a sense, these minds are very, very generic. They can behave in general ways. So it almost means that Shoshin is not just a game. It's a platform that is programmable. So it means that Shoshin needs to provide some kind of Turing completeness. And I think a simple way to provide Turing completeness is just throw a VM at it. So Shoshin, if having its own VM, would allow more general representation of minds and behaviors in the Shoshin game. It doesn't have to be the state machine thing I would describe. It can be a neural network, for example. I think that would be possible if we have a general machine that runs Shoshin. We're calling it application-specific VM, but we haven't really started this because our focus is in playtesting right now. Yeah, that's Shoshin. So that QR code would lead you to a Google form where we ask you strange questions, and if we like your answer, you will be in the playtesting.
So is it like building a brain from each of users, so they can train their brain and through intent or mind or body?
Yeah. I can playtest now live, so you get to know, like, understand how the brain is built.
Yeah, that would be great.
But I think our vision is that we don't want one person to make one brain. Our vision for this really, and we don't have to be the company that make this, our vision for this is like F1 tournament, where you have teams participating, and they're not single person teams. Entire companies with factory of builders and testers and sponsors. We want a team of people to, like, maybe one DAO make one agent, or one DAO make one brain that participate in competition.
Oh.
Yeah, I think it resonates a lot with people over here, because I think Nonce is one of his core pillars is community. And I think maybe the reason why community and trust is really important in blockchain is because Ethereum in itself is a world computer that is multiplayered. So the coordinations and the trust between the players for this computer is very crucial, because in your single player computer you can do anything you want, you execute whatever you want, so you don't have to trust another person. But just like co-working space, you guys have a bunch of different rules. Probably use the kitchen clean, or like we need to be able to admit a member who we can trust to use the kitchen clean. Similar in a way that when you're sharing the computer, world computer, the trust is the most important component of it. And I think if we can actually build a simulation or world on top of this computer, one of the most interesting activities that you can do is create some kind of fun game or a world where multiplayers can collaborate to create something on a singular mission. In this case, it'd be just fighting games. Just think of it as like a boxing game or F1 tournament, but it's for multiple players to collaborate to make the best boxing robots, and we're fighting with each other. And I think that is somewhat similar to in line with our thesis about world computer. You need some kind of public-facing or easy-to-use kind of interface so that people can do activities over there. Just like, in your computer, nobody deals with your CPUs or binary calculations or any of these. We have GUI or operating system that simplifies everything so that we can execute a task. Nobody cares about like what kind of calculation actually goes behind your computer, or what kind of, I don't know, probably there must be a lot of methods of how to calculate this and which one's a little better than this. Or even for chips, like you can do like what he was working on, photonics chips or quantum chips that might come out about. But as a participant or user of this machine, not many people actually care about it. And I think that should be the case because it's too much complex. It's as if like when you're driving a car, you only need to care about a steering wheel and the engine and a brake and a gear. That's it. You don't have to think about, how does the engine combustion works and what kind of things works the best. Those are for the engineers or the builders of the cars to take care about. But as a user, those are not the concerns, and you shouldn't be using those at all. So that's kind of like how I thought about this world computer. So we're in an age where the world computer doesn't have the operating system or the GUI that makes it easy for users to onboard. Because right now, if you go talk to friends who are not in this house to talk about blockchain, all of them will be like, oh, this is too complex for me to join, or this is just too scary for me. So that's kind of like our thoughts. It's some kind of layer needs to be built so that it's easy for everyone to use it and don't really care about your TPS or like, I don't know, which layer one you use or which rollup you should use. It's as if like you're thinking about like you're buying a computer, which CPU is the best, like, or like which CPU like you should use. I mean, some people do it, but as the end user of the computer, I don't care. Like I just need something that runs my browser or runs my Excel sheets. That's it. And don't even know how Excel sheets calculation is being done or settled on in your own computer. So that's our thoughts are. And in order to get there, we need to do a lot of experiments like this to figure out what is the best way to coordinate this multiplayer experience of making something together. And we'll learn something by making this, by having users to participate, which will later help us to figure out what is the most native way to interact for this world computer. So I hope this makes more sense of why we do what we do, these experiments. But Thomas will, Guilty Gyoza is much more well known in his Twitter handle and Telegram handle of Guilty Gyoza. Will show you how this multiplayer collaborative game called Shoshin is play testable.
Yeah, I was called Thomas in a previous life, but I think no one cares.